Correlation is a summary statistic between -1 and 1 that describes the strength and direction of the linear relationship between two variables. It's denoted by big R or a little r, or sometimes by rho. The looks like a P, but it's the Greek symbol. So it's a statistic, it's a measure. I'm not putting the equation and the calculation for the measure here. It's a little bit complicated, and most programs compute it automatically. But it's a statistic, it's a computation, and it gives out a number. And if the number is negative, like this one here, then that means it's it's a negative relationship, negative rho. If the number is between negative and 0, it's a negative relationship, but with different strength. So that depends. This one here is not calculated. If the number is between 0 and 1, it's a positive relationship. So if it's a positive rho, it's a positive R, positive relationship. If it's 1, it's a perfectly positive relationship, very uncommon to see. And if it's 0, there's no relationship. And once again, we're talking about linear relationship here. And this measure, we usually call it a correlation coefficient, a summary statistic, correlation statistic, correlation coefficient. And actually, there are a few ways to calculate it. And the most common one is the Pearson coefficient and the Pearson calculation. And once again, just a summary of what I mentioned: positive P is positive correlation, 0 is no correlation. Negative, I'm sorry, not P, but rho, negative rho is negative correlation. 1 is perfect correlation in the positive way, and -1 is perfect negative correlation. So here we have some correlation values and the graphic representations. So here our correlation is 0.33. We don't have a line, but you can imagine a line maybe goes something like this. So we can see it's positive, and we can see it's mildly strong. So the numbers can be for positive between 0 and 1, right? So what is strong? Is it strong greater than 0.5? Greater than 0.5 equals strong. Well, let's take a look. This one here is 0.69. And notice that it doesn't have to do with the slope, with the degree of the slope. It has to do with how together the points are. So in this case here, the points are very close together in the line. So there is a little what we call covariance. And we have a very high correlation here, 0.98, almost 1. Here's 0.69, and here's 0.33. And here the line looks almost flat, almost looks like horizontal, in which case we wouldn't really have a strong correlation because, but it gets a little bit complicated. But here we have a perfect correlation because all the points are on the line. Here we have on the negative side, here's calculated 0.64, also strong. So in terms of strength, this is strong correlation, but negative. And here also very strong correlation, but negative. Here, not a very, it says positive, so looks like it's this way, but it's a very weak 0.077. So you may ask, so what about 0.3? Is a strong or weak correlation? What about 0.4 or 0.2 or 0.45? Well, the answer is it depends. So it depends on the different context that you're working in. And there's an interesting article here you can read about. So in some technology fields where the impact of maybe a weak correlation between, for example, safety over equal can result in people's death, in this case, you really want high correlation between the safety of your vehicles and the lack of accidents, right? So maybe you're looking for something like 0.95 or above for a correlation. Now, in the medical field, actually, also similar because life is involved, but because also there's more ambiguity because biological systems are not like mechanical systems. So 0.3 may be considered actually significant or strong relationship. And actually, we see that also in the social sciences. So, and maybe in human resources, point 16, and in other kinds of situations too, could be considered a low relationship, low R, low correlation, but but because it's large enough that it might impact a lot of people, it also can be significant, and it may also cause attention to for something to be addressed. So it really depends on the context that you're working with, and then once you become more knowledgeable about that context, you will understand what is a strong or weak correlation. Next, we'll talk about correlation and causation.